Hello class, this is lecture 6 for Econ 4001.02, and I'm your professor, John Raybeck. So this lecture is going to cover variations on budget sets, so how to talk about things like taxes or savings, goods with endowments and other things, right? We're also going to discuss restrictions on budget sets, and these are going to be quotas or rationing or also another one we can do is subsidies as well. So a quota or a ration is when you limit the amount of stuff that someone can buy. And similarly, a subsidy is when you're going to give someone something. So how do we draw these budgets? And the last one is going to be discussing budgets when you have endowments. So what happens if you start out with something and then you can buy or sell these goods on the market. And all of these will end up being things that look very similar to the linear budget setting. And with that in mind, we'll get started. So the first one we're going to study is taxes. So suppose we're trying to consider the effects of a tax on the purchase of housing, where we'll think of good one as housing, and everything else you purchase is going to be given by good two. So for this case, we're going to first introduce an absolute tax. So this T1 is going to be in dollars, right? So this is something like dollars per good one. And this just adds directly to the price, right? So this is, if you're thinking of adding like a penny tax or, a $10 tax to buying housing for every unit of housing you get or something like this, right? And here we're going to say that the tax on the second good is equal to 0. And this is going to be a budget then with an absolute tax on good one, right? So here's the absolute tax. And the reason we call it an absolute tax is because it affects the level of the prices. We could also call this a level tax, right, since it refers to the level of price one. Another type of tax is a relative tax, where T1 is now some percentage of the original price of P1, right? So we'll draw this in a different color. We'll use lime green. So this is going to be the relative tax. And this is going to have no units, right? So this is just a percentage of whatever the original price is. With this in mind, we can consider how we can graph these two budgets now with the tax information. So we're going to do that on the next page. So the level tax on good one budget will look something like this. And I'm just going to graph the budget line right away, right? So we know whenever we think of a budget, we're normally going to think of things that are less than or equal to the income level M, but we're just going to have an M here and set it equal for right now. So if we do this, we can rearrange this equation to get everything in terms of x2, and then we get x2 is equal to M over P2 minus P1 plus tau 1 over P2 times x1. So if we have to graph this, it's going to look actually exactly like our linear budget, except we're going to have a different term associated with the slope and a different term associated with the intercept on the term that has the tax, right? So here, let me put in my axis labels. So here's the most of x, or of good 2 that I can purchase when I purchase 0 of good 1. So in this case, it's still going to be m over p2, right? So nothing's changed here. The next thing that's going to be a little bit different is we're going to have the horizontal intercept be, m over p1 plus t1. Right, so now I need to also divide my income by the tax because there's a tax on every unit of the good. Again, this is just the equation for a line, so we don't need to worry about, anything weird happening with the budget. We're just going to have it be represented by this. And then we can again find the slope on this budget line, which is just given by this term here. And this will be negative P1 plus tau 1 over P2. Right, so that's the slope. So now if we think about what we, had before, changing tau 1 is, or changing the tax is exactly like changing the price of good 1, right? So it's going to affect the slope, and it's also going to affect this intercept here, right? So, you want to think of this tax as, pretty much exactly like a price and how it's going to affect people's behavior. The next thing we want to do is, we'll also draw a graph real quickly. The relative tax, and here the relative tax will give us like a very similar budget, right? So if I have a relative tax on the price of good 1, so this is relative. In order to get an equation for my budget line, I'm going to repeat the same procedure as before, but now I'll get something a little different. So I get income over price of good 2 minus P1 times 1 plus tau 1 over P2 x1. Right, so this is going to be the slope now, and we'll have a different budget line here. So do this one in lime green. Again, the tax doesn't affect the most of good 2 we can purchase, but it will affect the intercept here, right? So this intercept is now going to be m over P1 times 1 plus tau 1. Right, and I'll throw in the budget line there, and the slope then is going to be just given by negative P1 times 1 plus tau 1 over P2. So this is just how we represent these budgets. Again, the tax is really just entering into the price of good 1, essentially. So what does this mean practically? Well, for any level tax on good 1, I could find a relative tax. But one thing, you might think is maybe these taxes are actually perceived by individuals differently, right? And in this case, you wouldn't want to use this kind of modeling device because it doesn't allow you to have, a level tax or a percentage tax, judged differently by the consumer. For example, if you're thinking about a tax on something like a car, maybe a 1% tax doesn't sound too bad. But if you translate this to levels, that could be something like $1,000. And the other thing is just, these taxes, if it's a level tax, this is something that's kind of fixed regardless of the good, right? So this would say it wouldn't matter if I'm buying a Ford or a Toyota, you're going to pay the same tax on the car. Here, this tax is going to, vary by price, right? So if I buy a high-end Toyota, the tax will affect my purchasing power different than if I buy a low-end Toyota. And similarly with a Ford or something like this, right? So yeah, that's how you get taxes in, and that was a little discussion about whether or not this is a reasonable assumption. Great. So the next thing we're going to discuss is going to be savings. So how do we map this into the framework we're using? So imagine you can consume today. So today is going to be X1 or tomorrow, and that's given by good 2. Right, so if I'm choosing between these two things, we're also going to need some way to think about how your income is generated, right? So let's say you're going to be paid X1 bar today and X2 bar tomorrow. Just, kind of a caution here, whenever you see something with a bar over it, these will generally be fixed quantities in class, right? So fixed. And these things here, the X1 and X2 are things that are actually chosen. So that's just one thing to make note of. So to map this into something that makes sense, we're not going to have prices on what you consume today or tomorrow, but instead we're going to have an interest rate. And here the interest rate is going to be denoted by R. And you can borrow money at an interest rate R, or you can save money at interest rate R, but you must pay it back tomorrow. So the idea is that you can't overspend your income forever. So from here, we're just going to write down the most that you can consume tomorrow. So if I think of how much you can consume tomorrow, this is going to be the amount that you're paid tomorrow, and it's going to be the amount that you save, right? So here, if this is greater than 0, this is saving. And I'll have it in green. And if it's less than 0, this means you're consuming more today than you are paid today. So this is going to be borrowing. Right, so you can save or borrow in this environment. But now, so this is how much I can consume tomorrow, given what I consume today. But I can rearrange this equation in order to get something that looks like a linear budget, right? So here I have, 1 plus R minus X1 on this side. I just move it over to the other side. And then this is going to be something that behaves essentially like a price, And here, consumption tomorrow doesn't have any price associated with it. And then here we see also that this is going to limit the amount that you can purchase in both periods, right? So my total purchasing is limited by the amount I'm paid tomorrow and the amount I save and gain interest on at rate 1 plus R. So again, this maps right into a linear budget. So we started with something where we didn't have names for these X1 and X2s other than thinking of them as apples and bananas. But we just showed that we can map, savings problems, which we think are important when thinking about like retirement or the debt of a country or something like this into this setting. So how do we graph this? We're going to graph it the same way we normally graph these things. So first, let me just write down the equation I had before, right? So this is 1 plus R, where R is the interest rate, plus X2 is less than or equal to 1 plus r x1 bar plus x2 bar. How do I graph this now? Well, sorry, let me just make my axis on this graph. So horizontal axis is x1, vertical axis is x2. The first thing I can do is just, plot x1 bar and x2 bar, right? So let's say x1 bar, x2 bar is here. I know I'm going to be able to consume this, right? Because this is just consuming the amount of money I make today and the amount of money I make tomorrow. So we'll let this point here be given by x1 bar and x2 bar. And then you might, using the same intuition we had as last time, we can find the boundaries on x2, right? So here, the boundaries on x2 are going to be given by x2 equals x1 bar plus x2 bar, oh, sorry. 1 plus r x1 bar plus x2 bar minus 1 plus r x1. Right, so first we can just think of the most x2 and x1 you can purchase. These are going to be given by the same kind of thing that we normally have. So let me just draw this line through here, because again, we know that we have a line for this equation. I'll put this in blue and draw it here. So again, this is going to be, 1 plus r x1 bar plus x2 bar. And here there's no dividing by anything, right? Because the most I can consume tomorrow is just what I make tomorrow and everything I save today. But I need to just save all of the money I would make today. We can also look at the amount of x1 you would purchase. And in this case, we're going to need to take this number here, which is essentially our income, and divide it by the price of good one, right? So, and here the price of good one is this 1 plus r, right? So if we do that, we end up with x1 bar plus x2 bar over 1 plus r. And you can also just kind of figure this out by thinking about the problem, right? So the most I can purchase today is my income today, plus if I borrow completely against everything I have tomorrow, right? So this is borrowing against everything, and you need to pay it back. So you can only borrow x2 bar over 1 plus the interest rate. One last thing, just how do I, map different regions of x1 and x2 into that saving and borrowing that I mentioned before? Well, here, if I purchase more x2 than I start out with, this is saving. And I'll do borrowing, I guess, in maybe pink. So this is the region where you're going to be borrowing. So that's kind of interesting. And you know that we can represent this. And finally, we can really think of this as having a slope, or I mean, it just does have a slope. And this is equal to -1 plus r. So here, the opportunity cost of, you know, trading off something just depends on the interest rate, right? Op cost just depends on interest rate. But again, we're able to model this all with a linear budget. So, you know, savings is no problem. We can talk about savings using our setting, and we can talk about it, you know, using the same kind of language we used before for budget sets. Great. The next thing we're going to talk about is subsidies. And subsidies is just, you know, giving someone some good, free amount of some good. A-M-O-U-N-T of a good. Right, you're giving someone something. You're subsidizing their consumption of that thing. So for this case, we're going to say x1 is food and x2 is everything else. We're going to consider giving the individual subsidy of food f, and this is some positive amount of food. And now our budget is going to be a little bit more complicated, right? So we can express our budget using this piecewise linear representation before, which makes some substitutions basically from the budget, right? So here we see that if x1 is less than the subsidized amount of food, for all of these purchases of x1, I'm able to spend all of my income on good 2. And similarly, as soon as I purchase above f, I need to start paying for it, right? So once I purchase more food than my subsidy, I need to pay for it, and that's represented by exactly this, right? So if x1 is greater than f, you need to pay for it. I could have written this down in a different way, right? So it's still a piecewise linear function, but you know, I would have p2 x2 plus p1 x1 minus f if x1 is greater than f, right? So I could have represented this that way and as a set of stuff. For this one, it's a little bit trickier, right? So I would have p2 x2 you know, less than or equal to m if x1 is less than or equal to f, right? And the reason is just I don't spend any money for any food purchase that's less than f, right? So this is how you could represent it using our standard budget. Oh, and there would be a less than or equal to m here. Great, so how do we graph this then? I'll just clear that. So we'll go from the form that we were given here. So we have x2 less than or equal to m over p2 if x1 is less than or equal to f and m over p2 minus p1 over p2 x1 minus f if x1 is greater than f. Right, so that's what we want to graph. How are we going to do this? Well, let's put in our axes first, and let's mark our horizontal axis with x1 and our vertical axis with x2. So the first thing we want to do is just kind of mark this F point, right? So the amount of the subsidy is going to be this F. And we know for everything less than F, we're going to be able to purchase this M over P2. So this is just going to be as large as possible. Right, so this means that our budget will look essentially like a straight line. Our budget line will be a straight line to that point. And then after that, we're going to have a line that looks like the normal budget line, but with a different slope. Right, so this is going to have slope of negative P1 over P2 still, right? So that's still going to be the slope of our line at this point, right? And then the next thing is just to think of, well, what's the most x1 I can purchase? And here, you know, it's going to be pretty much what you would expect of it, right? So suppose you spend all of your income on good one, you get that, but you also get the money from this, or you also get the food from the subsidy. So this will be M over P1 plus F, right? That's the most food I can actually buy in this situation. And you can get it through plugging it into the equation, but you can also get it just by, you know, thinking about this pretty much logically, right? So M over P1 is the most food I can buy with my income, and I can always get F for free, so that's going to be the maximum purchases I can make. Great. So that was subsidies. Another thing we can consider is quotas, and this is going to be a limit on consumption. So again, we'll suppose x1 is food and x2 is everything else. Here, consider giving the individual a quota or ration of food denoted by Q. In this case, the budget set can be expressed using this kind of representation, right? So I can only purchase x1 that's less than the quota, and I should not have this F here. It was meant to be quota on food, but just Q makes more sense. So I'll update that in the slides. So this is the budget set representation when there's a quota or, you know, rationing, something like that, though. So that's another name for a quota, is just a ration. Great, so how do we graph this? This one's a little bit easier than the subsidy, right? We didn't need to deal with too many piecewise linear things. So it's just x2 less than or equal to M over P2 minus P1 over P2 x1 if x1 is less than or equal to Q. Right, so we'll draw the graph here. So first we'll put in our axes, then we'll put in, you know, our labels on our axes. The first thing we want to do is, you know, we just know that the amount of x2 I can purchase isn't affected by the quota. So let's start out by putting our most preferred, or the most x2 we can purchase, which is just going to be M over P2. So the same kind of thing that we've been doing before. The next thing we want to put in is this quota Q. So let's have this quota here. And we'll have it go up there for right now. What will our budget line look like? Well, we're going to have some normal trade-off, and then we'll hit Q, and then we just won't be able to purchase any more X1, right? So remember I'm just limited in that I can only purchase at most Q units of X1. So that'll be my budget line, where this is supposed to be a straight line in blue, but you know, I'm not perfect here. And then the the things that you can purchase are going to be everything below this, right? So the yellow is what you can purchase. And also the slope here is going to be the same as it normally is, right? So it's just going to be negative P1 over P2. Great. So that was the subset or the quota / ration case. The final thing we're going to talk about is how to deal with endowments. So imagine we're purchasing apples and bananas, and you're actually endowed with some X1 bar and X2 bar. So you're an apple and banana farmer, and you have some fixed amount that you start with. Then we're going to also assume that you can buy or sell each good at a fixed price, P1 and P2, right? So P1 for apples, P2 for bananas. In this case, your income is decided exactly by how much you're endowed with or you start out with, right? So in this case, we're going to have a constraint. And the only thing that's going to be different is that we're replacing income with this part. So this is essentially our income, right? And this is really similar to the time budget, right? So really the time budget is a special case of the endowments, but it's easier to just start out with the time budget because it makes maybe a little bit more intuitive sense. And now the prices are going to tilt around the endowment, right? So before you had the prices tilting the budget around, you know, an endpoint, here they're going to tilt the budget around the endowment. And I'll try and show that through a graph. Clear my drawings. So first, let's put our axis here. And let's label our axes. So again, X1 is here, and X2 is here. I'll write down the budget line, right? So I'll simplify it too, just because this should be something that you're getting familiar with. So we're going to have X2 is going to be less than or equal to P1 times X1 bar plus P2 X2 bar. And this is going to be divided by P2. And then again, we're just going to have our normal slope minus P1, P2, X2. Oh, sorry, X1. Right, so that's the budget. We're going to do the same thing we did in the time budget case. So first, let's find our X2 bar because we can know we can purchase at least what we start with. And similarly, our X2 bar. So we'll say it's that point right there. Again, we know we're going to have a line going through this point. So we'll say it's here. And now, again, we're going to find our endpoints. And you can either kind of deduce these or you can use the equation to get them, right? So the most X2 I can get should be if, you know, I purchase, or if I keep all of the X2 I'm endowed with, and then I purchase the, you know, the rest, or X2 with the X1 that I can get. So this is going to be X2 bar plus P1 over P2 X1 bar, right? So P1 times X1 bar is the amount of money I get from selling all of my good one. And then I divide by P2 because I'm then buying good 2. And similarly, we can find the endpoint here. So this will be X1 bar, and then we'll just, you know, flip the reasoning, right? So now I'm selling all of my good 2, and then bind good 1. So you divide by P1. The slope of this budget line is still going to just equal negative P1 over P2. And we'll label some regions here. So here you buy X2 and sell X1, and the reverse here, right? So in this region, I should use a different color. I'll use pink. Buy X1 and sell X2. Right, so this is what it means to be in these regions, right? Because we're thinking of starting out at some price, at some endowment of good 1 and good 2. Oh, speaking of which, this should be a 1. One last thing I want to think about is now if we change P1 to say increase, there's 2 effects that happen, right? So first, you get more income. But also, 2, good 1 is more expensive. More dollars. Right, it costs more now. So how are we going to graph this budget line? Well, if the price increases, I can still purchase the same amount of the good that I had before, right? So I know my budget line needs to be going through this point. And really, I can represent it then by something like this, right? So here I get more income if I want to buy X2, right? So if I was buying X2, I can buy more, even more X2. But if I was buying X1, I'm only going to be able to buy less of this, right? Because the price increased. So the budget sets are going to tilt through this kind of line then, right? And you can do the other, you can get the opposite behavior by increasing the price of P2 or, decreasing the price of P1. So you might want to play around with the different ways that you can do this. The other thing is that, let me pick a color. Income is going to increase when X1 bar or X2 bar increase. Right, so if either of these increase, or if both of them increase as well, your income's going to be going up, and similarly, your income is going to be going down when both of your endowments go down, right? When X1 down or X2 down. And this is just, again, holding everything fixed. So in order to get those outward or inward shifts of the budget, you now need to give someone more endowment. And one thing to do at this point is to go back to the time setting and try and play around with it and see, what happens when you increase or decrease the interest rate, say, right? It's going to induce exactly the same kind of tilting behavior. So you should check that out. Great, so we discussed different settings to interact with linear budgets. You know, in the live lecture, we also talked about how to have things like quantity discounts, which are really just combining stuff from the subsidies or, you know, quota type settings where you're, you know, setting the price to depend on where you are in the budget line. And this will cause various kinks in the budget curves. But for the linear setting, you know, this can handle savings, endowments, subsidies, taxes, a bunch of stuff. So you can really model lots of behavior using this framework that we're developing in the class. And also quantity discounts can be modeled. So that was the other thing I was saying, using the tools here. So yeah, that's it. Thanks for listening, and I will see you soon.